Okay, so what do we get? Well, F is easy, right? So it's right. And that equals, well, we can write out what that equals because we just plug in, put a TI star around, put a TI star between each of these and the square, right? A TI star on each of these, and we have our expression for F. Okay? Delta S. Is what? Well, it's V at TI star times delta TI, where V is a vector, right? And what's V?
Change in position. Rate of change in position. Gotta get off that word. Yeah. Oh.
Okay? I mean, your position is xi plus yj plus zk, right?
Yes.
So there's your V of t. Okay? So V of ti equals, well, I'm not going to write it out. We're going to put a ti on each of these, right? And I'll just assemble this. Okay? Now it's going to be G big M little m over this thing to the 3 halves, where this thing is x of ti star squared plus y of ti star squared plus z of ti squared, right? So I'm not going to write that out because what I really want to do is write out this times the vector, right? So it's x of ti star I plus y of ti star j plus z of ti star k. I don't know what that looks like from where you are. Doesn't look too good when I get close to it. The board's a little rough there, and I'm not writing that carefully. Okay. Dot x prime of ti star I plus y prime of ti star j plus z prime of ti star k. Okay? Which equals, and then times delta t. Right? And what's the dot product? Well, we can write this out. It's not going to be as long as some of the other expressions. I think I have room. Okay? Now I'm going to write the G, big G, big M, little m, over now it should be obvious what I'm writing, but it's not easy enough to read from back there. It's x of ti star plus y of ti star plus z of ti star, but each one of these squared, right? To the 3 halves times what? So the dot product is just x prime plus y prime plus z prime, right? and then we have a delta t on the end. Okay? So I'm going to kind of do it this way. X of ti star, x prime of ti star, plus y of ti star, y prime of ti star, plus z of ti star, z prime of ti star. Okay? Times delta t. No square root of anything because you're not doing distance, okay? I mean, this will give you, the magnitude of this will be a distance, right? The magnitude of this factor is just your square root of x prime squared plus y prime squared plus z prime squared. Okay?
So why don't we get that factor? Why don't we get a square root factor?
Because there's no square root in f dot delta s. We're integrating f dot delta s.
There's a square root in there underneath the 3 to the top, 3 outside 2, technically.
You could think of this as being the square root of the sum of the squares of these things times a unit vector in this direction times delta ti. So if you wanted the square root, you could write it, but having written it, it would articulate with the denominator of the unit vector and divide out, and you'd be back to what you have here. Okay? If you understand that. So right now,
alter the different positions over time into a average velocity. In this case, we'll need an average velocity to close to vectors.
yeah, what he said. Couldn't understand it, but I bet it was good. Okay? Think about it. Talk about it. Better than listening to me. You got to sort it out. All I'm doing is giving you stuff to sort out. And then maybe, if you need to, you go back and look at the video and learn what you need to learn. Okay? So there it is. All you got to do is integrate this. And everything now, there are no vectors left, no dot products, it's just this mess. Okay? Now, if you don't have nice x, y, and z functions, and you probably don't to parameterize this thing, you're going to get something you can't integrate. Okay? I'll make this an fi delta si, because we're just talking about the ith interval. Okay? So the sum of fi delta si from I equals 1 to n approaches the integral from a to b, our parameter of t, right? Our limits on our parameter t, of x squared plus y squared plus z squared to the 3 halves times x prime plus y prime plus z prime dt, where all these x, y, and z functions and their derivatives are evaluated at t, right? So if I give you the parameterization, you can write out exactly the expression you have to integrate.